everyone, in this video we are going to discuss how to take Laplace transform of some of the basic signals in MATLAB. And we know the Laplace transform of these signals. For example, we know the Laplace transform of the unit impulse signal, which is 1. We know the Laplace transform of the unit step signal, which is 1s. And the Laplace transform of t, which is a ramp signal, is 1 by s square, because we know the formula that Laplace transform of t power n signal is n factorial divided by Sn plus 1. So whatever is the power of n in the numerator, we will take that factorial, and in the denominator we will have Sn plus 1. Fine. For example, Laplace transform of t square is 2 factorial, which is 2 divided by s2 plus 1. S2 plus 1 is 3, so we have 2 divided by s cube. Similarly, Laplace transform of t cube is 6 divided by s4, because 3 factorial is 6. And the Laplace transform of sine bt, where b is some constant, is b divided by s square plus b square. So if b is equal to 2, if we have sine 2t, we have 2 divided by s square plus 4, because 2 square is 4. Similarly, Laplace transform of the cosine signal is s divided by s square plus b square, where b is the constant. Laplace transform of the exponential signal of the form e power minus at is 1 divided by s plus a. If there was plus at, if there was no minus here, we will have a minus here. So we have opposite signs from here and here. If we have minus here, we have plus in this Laplace transform. If we have plus here, we have minus in the denominator of this Laplace transform. So we will go to the MATLAB and we will perform this. So first of all, I need to clear all the variables. I need to clear the command window. Then I will define a bunch of symbolic variables. For example, I will define impulse, unit step, ramp, etc. So I will give those variables some names. So let me give it a name: impulse to the unit impulse signal, STP to the unit step signal, ramp signal. Then we have sine, so I will give the name x to the sine signal, y to the cosine signal. T will be my variable in which all these signals will be defined. So I also need to define t as a symbolic variable, and then followed by exponential function, for example ex. So I have defined all these functions as symbolic variables. Now I need to define unit impulse signal, unit step signal in all these signals. So we know that unit impulse signal is defined by direct. The command used for unit impulse signal is direct. So I can simply say direct of t. So that's how I defined unit impulse signal. If it is not clear to you, you can watch my earlier videos in which I have shown how to define a unit step signal, a unit impulse signal in MATLAB, and how to plot that signal. So impulse is direct of t, and then we have the step signal. Step is defined as the heavy side. So heavy side of t will give me a step signal. After that I have ramp signal. Ramp is t. Fine. I will also define a parabolic signal here. Let me PARB. Let me call it a PARB. So ramp is t, parabolic is t square, it is 2t power 2. Fine. And then we have the sine function. So sine of 2t, for example. So x is a sine function. And then we have the cosine function. We want to take the Laplace transform of all these functions, which I will do in a moment. And then we have the exponential signal. For example, exp, I will say minus 3 star t. So exponential of minus 3t. So now I have defined all these functions. What I will do now, that I will start taking their Laplace transform. So I can say f print f, the Laplace transform of unit impulse signal is fine, and then I will say Laplace of impulse signal, which is IMP. Impulse signal is IMP, which is defined by direct. So this will give me the Laplace transform of unit impulse signal. I can again print for the unit impulse signal. I will say unit step signal. Unit step signal is Laplace of step. Step is defined as STP here. Step is assign a variable name STP. So I have defined Laplace of step, and then I will go on and define others as well. Laplace transform of, for example, ramp signal, which is the Laplace of ramp is defined as RMP. So I will write Laplace of RMP. I want to take the Laplace transform of RMP. Similarly, the parabolic, I can say Laplace of parabolic is defined as PARB. So this is the Laplace transform of parabolic, and let me type it here as well so that it's more clear. Parabolic signal, fine. There's the Laplace transform of parabolic, and then I can take the Laplace transform of sine function, which is defined as x. So I will say Laplace of x, and the cosine function, which is Laplace of y, and then the exponential function, which is Laplace of ex. So ex is my exponential function. So let me run this. Hopefully we will get the Laplace transform of all these signals. Let me save it. Hopefully in command window we will get the Laplace transform of all these signals. So the MATLAB is running. In just a few seconds we are going to get those functions and also their Laplace transform. So here we go. So here we go. If we can have a look, impulse is equal to direct of t, stem is equal to heavy side of t, which is the stem function. Then we have ramp t, parabolic t square, x was the sine t, y was the cosine t, and ex was the exponential function. The Laplace transform of unit impulse signal is 1. Find the Laplace transform of unit step signal is 1 by s, as I mentioned earlier. The Laplace transform of ramp signal is 1 by s square. The Laplace transform of parabolic signal is 2 divided by s cube. Parabolic signal is t square, so its Laplace transform is 2 divided by s cube. Then this was the Laplace transform of sine function, which was 2 divided by s square plus 4. And then the Laplace transform of cosine function, which was cosine 2t. So the Laplace transform of cosine 2t is s divided by s square plus 4. And then this was the Laplace transform of e power minus 3t, which is 1 divided by s plus 3. So that's how we take Laplace transform in MATLAB. Thank you.